Now we're going to perform a significance test to see if uh, uh, there's an effect, a positive effect of beers on the blood alcohol level. So if you drink more beer, does your blood alcohol level go up? Uh, Hopefully, people think this should be fairly positive, but we'll see what it says. Our null hypothesis is that the true slope between the two variables is non-existent. There's no slope. The alternative hypothesis is the thing that we're testing. We want to see that there is a positive relationship in that slope. Positive. If they said negative relationship, it would be less than. P is the true slope between number of beers and blood alcohol content. All right. Now we check the conditions. So if we look at the conditions, the first thing we do is start with the independence. We say assume each data point is independent. And then once you have that, you go and do a linear regression of L1 and L2. And then we look at the residuals. Now my residuals, so I'll just say residual plot. It looks something like this. So that's our residual plot, where this is your residuals, and this is number of beers. So if that's what we have, I'll type so we can say, uh, something about there seems to be a linear relationship between beers and blood alcohol content because the residual plot is scattered. Also, so that's our second condition. There's another condition about the residual plot. It says that the sigma is consistent and there are no fans. It doesn't start out small and end big or vice versa. So I could say, so we can assume that the standard deviation is consistent because there are no fans. All right, so we got 2 knocked out, or 3, 1, 2, 3. The fourth condition, we just want to take a box plot of our residuals. And when I do that, I get something. So that looks like this. And we can say these are the residuals. So the residuals are symmetric. So we can use a normal approximation. Now, if there was more than 30 data points, we could just assume normality with that, but since it's less, we'll just have to look at the residuals that we see. All right, finally, we get to calculations. Now it's somewhere between the easiest and most difficult uh, system. Here, we have t is b over standard error b. That's pretty easy. Now, we should say that we are using a linear regression t-test. And now, when we do this, I start by using the linear regression t-test on the calculator. And calculating that, I get a value of a t-value of 7.479 to 48. Pretty high t-value. Now, I don't show work here. And that's because the standard error slope is tough to find. You can look on your calculator and you can find the slope from the linear regression t-test, and the slope is b is 0.01796. So we could plug that in. But standard error slope isn't on here. And the formula for finding it is not a nice formula. So a quick, easy way to do it is if you look at standard error, I could find the standard error by taking if I multiply the standard error and then divided the t, I could take my slope, 0.01796, and divide it from our t, which is 7.48. My standard error slope has to be 0.0024. Now, this is just for showing work because our calculator already gave us this. Now our p-value is going to be quite low. So for our p-value, let me get it up again. It should be 0. It's 0.0000. I got to the -6, so 4. So 1, 2, 3, 4, 5, 6. So it's pretty low. Great. So we reject the null hypothesis because p-value is below alpha equals 0.05. So we have evidence that there is a linear or a positive relationship, I should say, between beers and blood alcohol content. All right, so that's our linear regression t-test.